Hello, welcome to another problem session. Today we have a really simple problem. You'll probably learn a lot from doing this problem because whenever there's a rolling motion, there's always a little bit of confusion about how to look at kinetic energy, angular momentum, and things like that. So there's a background information here. The kinetic energy in rolling can be separated into two kinds of contributions. One is kinetic energy of the center of mass motion, and a rotation motion about the center of mass. And in this case, what's going to happen is there will be an axis. So this is the z-axis coming out. So you can imagine z-axis that way, and so parallel to z-axis. So you can imagine it's rotating about this way. At the same time, the center of mass is moving that way. And if it's not slipping, then you can see that, say you mark an angle here. If it's rotated by that much angle, it will move, the distance that will move will be equal to that arc distance. So if in delta theta, if this is delta theta and this is delta x, then they are going to be related to each other. Delta x will equal to this arc length r delta theta, and in time delta t, so you can see there are relations between this velocity v and this angular velocity. So if the angular velocity is omega, then this v equals to r times omega. Okay. So the formula for this is simply half capital M VCM square. As the entire mass of the cylinder was placed at one point, not distributed like this, but at one point. And this one has to do with distributed. And so this will be equal to half about this axis we're talking about, rotation about this axis, moment inertia say is I. So this is going to be half I and this omega square. And the I here for this axis, I is half mr square. So now we can immediately see that this is 1/4 mv square, and this is half mv square. And then when we add this up, so kinetic energy of rolling cylinder is 3/4. So this is 2/4, and this is 1/4 mv square. That's the answer. It's a very simple problem. So say if you want to do extend this and say I want to do angular momentum. About this point O, about O. So it also separates LZ, so it's about rotation about Z, about O will be all, so we can say LZ CM plus LZ about cm. So it's going to be exactly same kind of separation. It's going to be two separation like this. So one of them, so let's tell you the same thing about here. So if the whole CM put all the mass here and it moves with V of the VCM, and this is the radius vector of the CM. So this is basically R of the CM, that's that vector, cross M VCM vector, and get the Z component. So this is X direction here. So axis is along the Z. So axis is along the Z direction. Axis is parallel to Z direction. Z axis is over there. So looking at that, what can we do? We need a Z component. Well, this would be simply this along the x-axis, and so this will be, if you, this R will have this as the lever arm, so lever arm times the V, so that will be just radius R. So it could be radius R M V. So that will be the answer for that part. I'm sorry, that this is not the answer for that part. Answer for that part about CM is we have axis again. So this is parallel to Z axis and it's going at omega. So that will be, this will be I about Z axis, and omega, which is Z direction. So this all positive Z is coming out for us. So I omega, and that's equals to half mr square, and omega is V over R. So this R cancels out, so is half mRV. Now both are in the same direction. This is along, if you go to right-handed rule in backward, and if I do, omega is going this way, so both of these are in the same direction. So L for this is pointed that way, and for this direction L is pointed that way. So this is actually minus here and the minus here, the Z component. So this will be minus half mRV minus RMV. So it's going to be minus 3 over 2, say mRV. And we'll talk about Z component, and Z is coming out of the board and out of the axis. Okay, you can see how this works out when there's a separation, and these two problems are just to show you how to separation. In the next problem, I'm going to deal with dynamic suppose the cylinder is rolling down the incline, and it's also rolling on the incline, then how to tell the acceleration, how to tell the speed at certain times, how much distance will cover on the incline. So that will be the problem that we'll handle next. Okay, talk to you later. See you in the next video.